How can we use the Punnett square for science? One way to use the Punnett square is to explain people's genetics. Let's say we have a brown-eyed mom and a brown-eyed dad, and they have a child that has blue eyes. Could brown plus brown really equal blue? Let's find out. First, you need to understand how genes work. Everyone has two alleles, which creates a gene. One allele could be dominant, which means it overpowers the other allele. If you have a dominant allele, it will always be represented as a capital letter. For example, a capital B represents the color brown because it is a dominant color. One allele could also be recessive, which means the dominant allele overpowers it. A recessive allele is always represented as a lowercase letter. For example, a lowercase b represents the color blue because it is a recessive color. So let's put this on a Punnett square. You have the genes of the brown-eyed parents represented as big B, little b. If you multiply the big B and the other big B, you get two big B's. And if you multiply the big B and the little b, you get a big B, little b. If you multiply the little b and the little b together, you get two little b's. So what does all those b's really mean? Two big B's and one big B, little b put together all represent the color brown. The only gene that represents the color blue is two little b's. So is it possible for two brown-eyed parents to produce a child that has blue eyes? Well, certainly. There is a 75% chance that they will have a brown-eyed child, but although it is a small percent, there is a 25% chance that they could have a blue-eyed child. And that is one of the ways that you can use the Punnett square in science.
Now that we've looked at how we can use the Punnett square to determine genetics in science, let's take a look and see how we can use the same method in order to do mathematics. So for multiplying numbers, say we have two two-digit numbers, 48 times 32. We can use our Punnett square to multiply these numbers and to keep everything organized. So we draw our Punnett square and we have 48 times 32. Now we don't want to use a 4 and an 8, we want to use 40 and 8 because when added together it gives us 48, but also we just need to make sure that we're keeping everything in its place. So since 8 is in the ones place, we just can leave it as 8. However, 4 is in the tens place, so we need to make it 40 so that our Punnett square works. So we see that we have 30 and 40 around this box. And basically when you're doing the Punnett square, you're finding the area of each box. And then we're going to add the areas together to get our official, to get the total area of the big box. So 30 times 40 makes up that first square or rectangle. 30 times 8, 2 times 40, and 2 times 8. So when we multiply them together, we get 1200, 240, 80, and 16. From here, we've got the areas of each box or each rectangle, and we can pull them out and add them together to give us our new number, which is 1,536. So we've looked at two-digit numbers. What if we have a three-digit number and a two-digit number? It works the exact same way. Your box or your Punnett square will just be a little bit bigger. So you can either draw it horizontal or vertical. It works either way. So we'll do 122 on top, and 87 to the side. And again, just keep in mind that you want to keep every number in its place. So when we multiply them all out together, so we've got the areas for each rectangle, and when we multiply them, we get 8,000, 1,600, 160, 700, 140, and 14. And again, you've now just found the areas for each. We're going to add them together to find the area of the total rectangle, which gives us 10,614. So we've looked at numbers. Now let's see if the same process works for multiplying polynomials. So what if we have two binomials, x minus 1 times x plus 5? Draw your Punnett square and you're going to do the same thing. And it's already got its place values because when you're doing polynomials, it's in order based on degree. So we've got x to the first power, and then we've got our constant, which is -1, and our constant 5. And just make sure we have x minus 1, so that 1 needs to stay negative. And then you just find the areas. So we're still looking at what makes up this box. And on one side we have x, and on the other side we have x. So x times x, length times width. Then we have x times -1, 5 times x, and 5 times -1. And we get x squared, negative x, 5x, and -5. And again, you're just adding your new terms together, and you can see that our like terms are 5x and -x, so we're just going to combine like terms. But you can just take them out of the box, add them together, and you end up, again, just make sure you're adding your like terms, which are -x and 5x. And when we do this, we get x squared plus 4x minus 5. Well, what if we have a trinomial and a binomial? Well, it works the same way if you had a 3-digit number and a 2-digit number. You're going to draw your Punnett square. It's just going to be bigger. And again, orientation doesn't matter. So we have 3x squared, 4x, -7, 4x, and -3. And again, we're going to find the areas of each small rectangle, add them together to get the area of the total rectangle. And all this does is just helps us keep everything organized instead of trying to distribute a bunch of different numbers around. So we have 4x times 3x squared, 4x times 4x, 4x times -7, -3 times 3x squared, -3 times 4x, and -3 times -7. We end up getting 12x cubed, 16x squared, -28x, -9x squared, -12x, and -21. And again, you can take a look and see that in the diagonal, we have our like terms. These are our square terms, and these our degree of 1 terms. Then just pull out your terms, and you can see again we have 12x squared, so we're going to add that to -9x squared, and we're going to add -28x to -12x. And when we do this, we get our new polynomial, which is 12x cubed plus 7x squared minus 40x minus 21.